just like the first section, I'm splitting the section into two because what you'll notice about our trig units is each one of the sections are jam-packed with a lot of information. So this has a couple of different things we're going to talk about when we're now going to introduce the Radian into our trig stuff. So this first part is just mostly focused on conversions. So there's actually two different types of conversions we're going to talk about today, both from degrees to something else, and then from that something else back to degrees. So a degree measurement works really well when we're talking about triangles, but when we're trying to apply it to other things, it's a little bit tricky to use. So what we then created is something called the Radian that actually can make the angles of a triangle, which actually apply to a circle, more applicable and much more subject. So the second part is kind of going through some of the applications that we can use with radians. So this first part we're just going to talk about some conversions. And like I said, there's actually two different things. So we're going to go from degrees to something else, including degrees. That's the first conversion we're going to talk about. And then the second conversion is going from degrees to radians. Before we do that, though, there's some definitions that we're going to go through. So that's the first couple slides. I don't make you draw as many angles as I should. So usually part of this is just getting used to how you draw the angles and the different shapes it makes. So usually I have you look at them and then kind of tell me a little bit about them. So I don't usually make you draw them, but I will talk a little bit about the parts of an angle. So this is considered an angle in standard position because most of the time when we talk about the different angle measurements, we're actually applying it to our XY coordinate plane. So if you look at this one, you can see the colors up here on my screen. So the blue lines are indicating the angle that we're talking about. We often put it on the XY coordinate plane. So there's going to be some sort of X value, Y value that we can attach to some sort of part of the angle. And then we have where we start our angle. There's a couple different points for that. This middle point at the origin, that's the vertex of the angle. So where the two parts of the angle meet is called the vertex. So that's typically what it rotates on is the vertex, is the common endpoint between the two sides. With our angles, typically our initial side goes on that positive half of the x-axis. So this blue line here that's going to go right on top of the positive half of the x-axis, that's where most of our angles are going to start. And then we typically rotate counterclockwise to get to the terminal side, or where the angle stops rotating. So we have our initial side of our angle, and then it rotates typically counterclockwise. But you will see this directional arrow, because sometimes we don't necessarily rotate that direction. We could actually get to this one if I just said, okay, rotate counterclockwise or clockwise just a little bit further. So you will see a directional angle indicating the direction that we're rotating to get to that terminal side. And then, like I said, in order for it to be in standard position, it just lies along the X and Y axis of the coordinate plane. So what eventually we're going to talk a little bit more about is there's actually a couple of different ways we can start at this initial side and rotate to that terminal side. Typically, we rotate counterclockwise. That's how all of our positive angles are set up, which is what the next thing we're going to talk about is. But we actually can start at the initial side and rotate clockwise instead and still end up in that same spot. We just have to rotate a little bit further, okay? So eventually we're going to talk about how we can have this angle shape, but there's actually a couple of different reference angles. We can say what the actual angle is, okay? Because there's a way to get there rotating counterclockwise, clockwise. There's actually a way that we can rotate a couple different times because it is going to eventually go in a circular motion. So all different angle shapes actually have several different representations to create that angle, okay? So that's just kind of the main parts of it. The big thing we'll really use later is the terminal side. So initial side doesn't change. It's always across that positive half of the x-axis, but the terminal side where the angle stops will change depending on what angle we're talking about. So then a couple more vocab things. Like I said, typically we work with positive angles and And what that rotation is for our angle, it's a counterclockwise rotation from that initial side. Okay, so with this one, here's our initial side. We rotated, and again, you'll see that directional arrow rotating counterclockwise to get to that terminal side of that angle. And so we'd say that's some sort of positive angle, which if I wanted to give it some sort of numeric value, see that's a 90-degree angle, 180. So we can say that's like a 200-degree angle. Okay, so then I would say that's some sort of positive angle. Now, if I want to rotate clockwise instead, the way we do that, so we can indicate direction as well as how far we're going, is if I want to rotate clockwise instead, I can rotate using a negative angle. So positive angles are counterclockwise, negative angles are clockwise. So if you see a negative angle measurement, that just means that we start from the initial side, and instead of rotating counterclockwise, like our positive angles, we rotate clockwise. So we're saying that that's a negative rotation. So for our initial side, this would be like negative 90, negative 180, so then like negative 220 or something like that could be our initial, our measurement for that. And like I said, today we're mostly focused on conversions, but again, we are going to be working with some positive angles, some negative angles, so you'll see some differences there. Right, so we'll do a lot more with angles as we continue with this section, but right now we're going to switch, and we're going to start focusing on our first conversion. And like I said, one reason I wanted to introduce this first was because some of our angle measurements I give you will be negative. And so I want you to know where the negative angle comes from, and that's from rotating clockwise instead of counterclockwise around our coordinate plane. Okay. So the first conversion we're going to do is something called degree minutes seconds, or DMS form. So basically this takes a degree that's a decimal and subdivides it into two other categories. Okay, where this is used a lot is like in GPS coordinates. Usually when with longitudinal and latitudinal directions, you get like some sort of degree, and then you get a minute and a second. Okay, it's really helping to pinpoint a location around the globe, because our globe is circular, and so you can't say, well, go 100.25-ish degrees. That's hard to locate. So then they take the degrees, or the decimal portion of the degrees, and they subdivide it into two other categories, minutes and seconds. Okay, so that's what we're going to first convert. So we're going to start with a degree that has some sort of decimal portion of it, and we're going to subdivide it into a minute and a second so we can get a quicker location for that degree. Okay, also where it's used is if you're ever flying a plane or steering a boat around the globe. Again, you can't say turn the boat like 125.36782 degrees. That's hard to narrow down, but they can, if they can subdivide it into two other categories, they can get a better location of where they need to steer their vessel to get to the point that they need to go. Okay, so that's one place that we see degrees, minutes, and seconds. So the ratios are fairly straightforward. One of them is something we've known forever, and one of them is something that they created so that it's easy for us to subdivide it into these two categories. So basically we use the ratios where 1 degree equals 60 minutes. So we can take that decimal portion of it and multiply it by 60, and that'll subdivide it into a minute. So it's a 1 to 60 ratio for degree to minute. And then the other one we've known for a long time, 1 minute equals 60 seconds. Okay, we've known that forever. So then they use the little, instead of saying minutes and seconds, they use the apostrophes to help indicate that. And I know they've also used that in inches and feet and other measurements. But 1 tick mark is a minute, 2 tick marks is a second. Okay, so like I said, the second ratio we've known forever. 1 minute is 60 seconds, so that's not new. So the new kind of ratio that we use is we're saying 1 degree equals 60 minutes. And so like I said, basically to convert that, we take the decimal portion of our degree and we can multiply it by a 60 and turn it into a minute. And then if we have a degree decimal from our minutes, we can convert that into a second. So to convert to a minute and second, we're going to multiply by 60. That's how we use that ratio. And we're also going to go backwards. So we're going to start with the minutes and seconds and convert it back into just a decimal format for our degree. Okay, so it's just a 61 ratio. So it's a pretty straightforward ratio. You just have to either multiply by 60 or divide by 60, depending on which direction you're going. So if you start with a decimal and you want to turn that into a minute and a second, we're going to multiply by 60 because we want to make it bigger. So we don't want it to be a decimal anymore. And then if we start with a minute and second and we want to convert it back into a decimal, that's when we divide by 60. So we take our decimal, we take our minutes, convert them back in our seconds, convert them back into minutes first, then convert the minutes back into degrees. So we're going to go through some examples now. So it should be fairly easy to notice whether it's in decimal degree form first or minutes and seconds. So if you look at your measurement that I give you and it has some sort of decimal portion to our degree measurement, then that means what we need to do is convert this portion, this decimal portion, into a minute and a second. Okay? So the first thing we do, because there are 3 parts to our DMS format, is the degree format is just the number that's in front of the decimal point. We actually don't do anything to convert that. That's going to stay a degree measurement. So we're just kind of cut that off. So it's going to be 329 degrees. So that's actually going to be the first part of my answer. So now what I'm worried about is taking that decimal portion and subdividing it into a minute first, and then if I need to, subdivide it into a second. So I'm just going to focus on the decimal portion. To subdivide it into a minute, I'm going to take that decimal, make sure you keep the decimal point with it, and we're going to multiply it by 60. Okay, because we want to make it bigger. So we want to take that, because that's technically in decimal or degree format, we want to make it into a minute, so we take our 0.127 times 60. So I get 7.62. So I've taken that decimal portion of my degree, and now it's 7.62 minutes. Okay? Everyone with me so far? So again, I have another decimal. Okay, I'm trying to work my hardest to not have decimals. So what I take from this as the next portion of my answer, again, just like I did before, whatever the numbers in front of the decimal point, I'm going to leave that as my minute. So I'm going to say it's 329 degrees, 7 minutes. Okay. So then what I subdivide into seconds is just like I did with the decimal portion of the degrees. Oh, stay there. I'm going to now take the decimal portion of minutes and subdivide those into now seconds. Okay. So I'm going to try to, as much as I can, to get rid of as many decimals as I can. So I took the original decimal that was a degree. I converted it into a minute by multiplying by 60. So now I'm going to take the decimal that's on my minutes and convert it into a second. So again, I'm going to take 0.62. And I'm going to try to convert it into a minute, from a minute into a second. So I need to make it bigger. So I'm going to multiply by 60. So I'm going to take 0.62 times 60. So it's 37.2. So then when we get to this point, we still don't want decimals. So sometimes it'll work out nicely that the seconds is the whole number. We don't have to worry about it. If you ever get a decimal on the seconds, there's no way to, there's not another subdivision category. So we can't just keep going until we we get rid of the decimal completely. So what you get to do once you get to the seconds portion is just round to the nearest second. Okay. So I still don't want the decimal, so I'm just going to say that that's 37 seconds. Yep. It's close enough now. So since we've subdivided it even further down into 3 different categories, questions about the first one? So now we can get our location to 329 degrees, 7 minutes, 37 seconds. We can pinpoint that location better than say, okay, go 329.127-ish degrees. Okay, it's hard to steer the boat exactly that amount. But again, they do have dials that they can specifically dial in a certain minute and certain second that they're locating, so they get a more accurate placement for the way where they need to go. Okay. So let's do the second one. So what do we keep around from the second one? Yep, the 213, that's going to stay our degrees. So anything that's above the decimal point is fine. That's our degree measurement for our degree minute second. So then we're going to take the decimal portion of the degree and we're going to convert that into a minute. We're going to take 0.875. What are we going to multiply it by? 60. Yep, because we have that 60 to 1 ratio. So if we want to make that decimal bigger, we want to make it a whole number instead of the decimal. We're going to take 0.875 times 60, and that converts it into a minute. So I have 52.5. Okay? So that's now a minute. Okay? What do I keep from that? The 52. Yep. So I have 52 minutes. So then what do I do with the 0.5? Yep, I'm going to take 0.5 times 60 because I'm going to convert that now into a second. Okay? So we take 0.5 times 60, which is 30. I don't know why I'm putting this in the calculator. Okay? So, like I said, up here with this first example, we had a decimal after we converted it into a minute, so you just round to the nearest second. With this one, it was a nice whole number, so you don't have to worry about rounding. So we're just going to say it's 213 degrees, 52 minutes, and 30 seconds.
So what would happen if we get to the second portion and we end up getting like 65 or 65 seconds?
Oh, that doesn't happen very often, but I don't think I ever did this time before. But you could just leave it. But most of the time I give you ones that are going to be within that 0 to 60 range.
Okay.
So you could technically then, like, yeah. But I don't think you should have to worry about that. Usually I'm nice to you. Okay, that did bring up another point though. Every once in a while, this first decimal that you get, if you multiply it by 60, it's a whole number right away. Okay, that can happen. So that would just mean you have a minute, but no seconds. Okay, so it is possible to get a 0 seconds. I don't give those to you very often, but that does happen, I think, on not today's worksheet, but on another worksheet. Okay, so it is possible for you to convert the decimal from the degree into a minute, but have no decimal. Okay, if they get no decimal of our minutes, that just means we have 0 seconds. Does that make sense? So any questions to take it from a decimal into a minute and second? So now we're going to do the opposite direction. So we're going to start with a minute and second, and we're going to go back into decimal format. So that's what always we do with conversions. We go both directions. So that way, on any time with a problem, if you have to go back and forth, we practice both. Okay? So we kind of reverse the process completely. So now we have this in degree, minute, second format. So we have 35 degrees, 12 minutes, 7 seconds. And we're going to take this and we're going to convert the minutes and seconds portions back into a degree. Okay? And like I said, you kind of have to reverse it entirely. So the first thing we start with actually is the seconds. Because we don't want to go, there's no nice easy conversion to take it right from seconds into degrees. So the first thing we do is we take our seconds, convert them into minutes, and then take all of the minutes and convert them into degrees. So we start from our minute or seconds, convert it to minutes, and take all of our minutes and convert it into degrees. Does that make sense? So if I have something that's a second and I want to convert it into a minute, division, yep. Because if I have 7 seconds, I want to figure out how many minutes that would be. I would take 7 divided by 60. That's going to be, yep. So it's 0.11666666666 so on. So we are going to round a little bit. And so typically, if you notice my first examples, we typically do 3 decimal places if we have to round. So just like this, I'm going to do 0.117. Okay. So that's now a minute. Okay, so I took from my seconds to my minutes. What other thing is a minute as part of my problem? The 12. Okay. So what I do is I take the 12, which is a minute, and now I have my seconds as a minute. I'm going to put those together. So I'm going to add those together. So it's 12 plus 0.0 or 0.117. 12.117. So I put both of my minutes together, and I'm going to convert it into a degree. Okay? So if I'm going to convert into a degree, what do I need to do? Divide by 60. I'm going to take 12.117 divided by 60. It's 0.20195. So it does terminate, so if you wanted to use all those decimals you can, but typically I just do 3, so I'm going to do 2.02. So then I'm going to put that with my other degree, so that's 35. So these are now both degrees. So I'm going to put my degrees together, so I have 35.202 degrees, and then and kind of the reason why you would need to go back from minutes and seconds, you're trying to figure out something with a ship and a triangle, and you're trying to find a distance. You can't really, in your trig function, if you wanted to find like the length of the hypotenuse or the opposite side, you can't really put minutes and seconds in sine, cosine, and tangent. So if they're ever wanting to kind of map out the distance between one ship to maybe the lighthouse or a ship from another ship, they can convert it back into a degree, a total degree, and then use the SOHCAHTOA to help us find the distance. So that's the one reason why we have to go from minutes and seconds and back into degrees, so we can use all the other stuff that we've done. Okay, so for the second example, what do we need to do first? Yep, take our minute or seconds and turn it back into a minute. That's and sometimes these divide evenly, but obviously not always. So I have 0.133333, so I'm going to do 0.133. Okay. So now that's a minute. So now what do I need to do with it?
Add it to the 50.
Yep, add it to my other minute, which is 56. So it's 56.133. So now those are all our minutes. We're going to convert those into degrees. What do we need to do? Divide this. So I got 0.93555, so I'm going to do 0.936. Now I'm going to put all my degrees together, so I got 89.936. Questions about to and from DMS? We're okay with calling it DMS, because I don't want to say degree minutes every time. So that's our first conversion. The next thing we're going to talk about is radian. And we're going to do a lot with radians from kind of here on out. But I like doing minutes and seconds a little bit. It's like, so whenever you look at GPS or we're talking about pick one of the pilot, ship captain, you're going to use that. Alright, so what a radian does, it links an angle measurement with a linear measurement. When you're working with degrees, really the only thing that degrees works really well with is trig stuff, with sine and cosine and tangent and all that. So it doesn't really play well with like any other formulas or anything like that. So if all you have is a degree measurement for a triangle or a circle, it's really hard to use that in other formats, like if you want to find area, or if you want to find the length of the arc of the circle, or there's just a couple applications I can think of off the top of my head. So what they did was they created a ratio, and they now call that another way to measure an interior angle. Okay? Because for the most part, when we talk about angles, there were triangles. But what we can do is with this radian measurement, it links the central angle, which comes from the initial side, rotating to the terminal side. So that's what the theta is right here. It's a ratio that's from the arc length of the circle, right here, to the radius of that circle. So it's a linear measurement. It's a ratio between the arc length of the circle, of that little angle, and then the radius of the circle. So since it's a linear measurement, we can actually use that eventually to find all kinds of areas. Like if we just wanted to find the area of that little pie piece of that circle, we actually use the radian measurement to help us find that easier. If we had a degree measurement, we could just find this distance if we want, using that, just that little portion of the circle. So we can use a radian to help us do that. What?
No.
Okay. Did you just do this in another class?
No.
Okay. So here it's kind of just a little bit of a small example. So if I know that, and they use this ratio, S is the arc length. It's so arc length, so if you see the letter S, what it's talking about is its intercepted arc here. I don't know why they don't use A. We'll use A for something else later. But they use the letter S. So that's measuring this distance here. And then R is the radius of the circle. Okay? So to get this interior angle that we're going to label theta, we can take the arc length and divide it by the radius, and that is our radian. So since if we say that the arc length is 5 and the radius is 3, we're going to say our radian is 5 over 3.
Is that just tan?
What?
Is it just tangent?
No, it's not this length. It's this curved length. So if you want to do the triangle, it would drop straight down. So it's not quite the triangle, it's just that that's a curved measurement.
So I'd say technically both sides of the radius here wouldn't be possible for it to be
What?
both the sides of the
This side?
the same length.
Yeah, this is the radius. This is this curved area. So it's more like a pie piece, not a triangle. Alright. So now that we're linking together radius and little pieces of the arc, what we can now do is we know a little bit about the whole trip around the circle, which is the circumference. So they started using radian measurements compared to that circumference. That's what this next slide is going to be. So the circumference of a circle is measured 2 pi r. That's where pi came from. It's a common measurement that kept showing up when you're finding the circumference of a circle. So they decided to label it pi. So remember, whenever you see a pi within any type of problem, pi is just a number. It stands for something close to 3.14, but it's not 3.14. It's actually several infinite number of digits behind it, so it's more accurate to use pi. So because we like exact values when it comes to trig, so that's why we put the letter pi in there, because it stands for that number. So to find a circumference of a circle, it's 2 pi r. So whatever the radius is, take it times 2 pi and you get the circumference of the circle. Well, we now know that we've linked the radian measurement, which is the arc of the circle, compared to the radius of the circle. if we wanted to find the radian measurement for the entire trip around the circle, that would be what's outlined here in blue. So if you see here, if our arc of our circle is the whole trip around the circle, which whatever the radius is, it doesn't really matter, would be the whole circumference. So that would be our 2 pi r formula. And then we divide it by the radius, like we would like we would for our radian ratio. It's arc divided by radius. What happens if you take 2 pi r and then divide it by r?
Just cancel out the r.
Just cancel out the r. So
It's
does
just
it doesn't really matter what the radius of the circle is.
This is 6.28.
So no matter what, whatever the radius happens to be, we're going to divide by the radius. So an entire trip around the circle in radians is the measurement 2 pi. Okay? So once they started linking it to the arc length of the circle, they started expanding that using the circumference. And so they came up with some common measurements for radians, because it doesn't really matter what the radius is. If you do the entire trip around the circle, which is 2 pi r, and divide it by its radius, the r is going to cancel out. So that's why you can see in the little print the arc length of an entire trip around the circle is 2 pi. And so we can use that common radian measurement in whatever circle we're talking about, because it doesn't matter what the radius is, because it's always arc divided by radius. If our arc's an entire circumference divided by the radius cancels out. Okay? So then they started applying that. Okay, what if I do that for half of the circle? So basically take this whole thing and divide it by 2. What would half a rotation in radians be?
Pi.
Just pi. Yep. So if you see the measurement pi, what that covers is this rotation from the initial side of our angle rotated halfway around the circle. That measures pi. Okay, that interior angle. So that's another common radian measurement that we use. So 2 pi is a whole trip around the circle. If you're rotating from the initial side to the terminal side, and the pi is a half a rotation. And the other one that's used quite commonly is what if I half and a half? So I just do like a 90-degree angle.
3.55.
Yep. So take the entire trip around the circle, divide it into 4 pieces. So really it's pi over 2. Is a quarter of the circle. So those are some common radian measurements that we end up using. And so since we know a little bit about rotation in degrees, we're actually able to come up with a pretty good ratio so that we can convert other radian measurements or other degree measurements to and from degrees and radians. Because we now know an entire trip around a circle is 2 pi, which we know in degrees. What's an entire trip around the circle in degrees? 360. So those two things would be linked. 2 pi is a radian. 360 is a degree measurement. We now know that half a circle is pi, and we're talking about radians. What's half a circle in degrees? 180. Yep. And then with this one, we know that a quarter of a circle is now pi over 2. What would this rotation be? 90. Okay. So those two things, those 3 values can always be linked between radian measurements and degrees. Okay. So we actually use that to help us with our conversion ratios. And the one that's most commonly used, because it's not working with too bad of fractions, we actually end up using the ratio between half a circle in radians and a half a circle in degrees. So we know that these two values are the same. Pi is a radian measurement, and 180 is the degree measurement. Okay, so we know those two things are equivalent. Pi is a half a rotation, 180 is half a rotation in degrees. So we can use that common ratio to convert anything we want from degrees to radians or from radians to degrees. So if you start with a degree, we use it as a ratio where what we're trying to get rid of is on the bottom of it. So you can cancel out the degree and then keep the radian around. So if you start with a degree and you want to convert to a radian, you multiply it by pi over 180. If you start with a radian and you want to make it into a degree, the radian goes on the bottom, so the pi goes on the bottom, so you can cancel out the pi and convert it into a degree, which is what's going to be left on top. Okay, let's do a couple quick examples. I may not do everything I have up here, because we're running short on time, okay? All right. So if we have a degree and we want to convert it into a radian, we use the ratio of pi 100, divided by 180 degrees, okay? Because what we'll do is we'll be able to cancel out the degrees and then simplify the fraction. So usually we like to leave these as exact values. So when you do this, you kind of treat it like a fraction. We're going to multiply straight across. So it's 110 pi over 180. We usually leave pi, okay, because we want to leave it as an exact value, but we can simplify that a little bit. So we're going to leave the pi there. How can I simplify that fraction of 110 over 180?
18 over 11 over 18.
Yeah. You get rid of the zeros. So it's 11 pi over 18. Okay. Now every once in a while you might be able to simplify a little bit further than that, but I don't think there's anything else that divides 11 and 18 easily. So that is the radian measurement for 110 degrees. We can work with negative angles. Just our answer is going to be negative. So we have pi over 180. So you multiply across. So you can get rid of the little degree symbol. We have negative 30 pi over 180. How can I simplify that a little bit? Yeah. So I can get rid of the zeros. And then, is there something that can divide the 3 and the 18? Yep.
I mean,
3, yep. So this will become 1. If you want to write the 1, you don't have to. Over 6, or I would just write it negative pi over 6. So essentially it just turns into a simplifying fraction. Okay? So that's from degrees to radians. So now we're going to go the opposite direction. Start with the radian and convert it into a degree. So all we need to do is flip that ratio. Because now what we're trying to get rid of basically is the pi. Okay? Because we want to turn that into a degree. So a degree can have a pi with it. So again, we can multiply straight across. So we have 360 pi over 3 pi. What happens if I have a pi on top and pi on the bottom? Cancel out. And then what's 360 divided by 3?
120.
Yeah,
What?
that number.
120. There you go. Okay. I guess we'll just use the plus one and we'll do that. So we multiply straight across. If you want to, a lot of times we just go ahead and get rid of the pi's right away. Because again, that's essentially why we use this ratio, is so we can cancel out the pi. So we just have to take 3 times 180, which is
540.
and then divide it by 4.
Is it negative?
Wait, it's 9. Isn't it?
What?
135.
Oh, yeah, no, it's not. I think that might
135 and we're at 6. I don't know why. Okay. And throw a little degree symbol.
What?
So we took 3 times 180, which is negative 540, divided by 4, negative 2.
That makes it good.
Yeah, we're going to do those later. Not tomorrow, actually. We'll do those next week. So today we're just going to get a little worksheet that has some conversion